Hi everybody, Mrs. Pesic here. We're looking at section 1.5, Analyzing Graphs of Functions. In this section, our learning objectives are to use the vertical line test for functions, to find the zeros of functions, determine the intervals on which a function is increasing or decreasing, determine the relative maximums and relative minimums of a function, determine the average rate of change of a function, and identify even and odd functions. In this section, we are looking at functions from a graphical point of view. So recall, the graph of a function f is the set of all ordered pairs x comma f of x such that x is in the domain of f. So for example, here's a function drawn, and any point on the function would have the ordered pair x comma f of x. X is our input and f of x would be our output. Okay, you do have a domain and range worksheet that you were given, so that is going to be part of what we'll talk about next time. All right, so let's talk about the domain here. Maybe this will help with the worksheet. So to find the domain for this particular function, and this function starts at -2, -1 right here, and it goes through 0, 3, and 1, 4, and 4, 1, and ends up over here at 5, 3, but that's an open circle at 5, 3, meaning we're going to go all the way up to that point but not include that point. So let's talk about what the domain would be for this function. That's going to be all of the possible x values. Really, that means how far left does the graph go, how far right does the graph go. So in this case, the domain goes from what x value? Well, it looks like our smallest x value goes all the way to -2, and it goes all the way to +5. So our domain is going to be -2, in interval notation, -2 to +5. Do we want to include the -2? Yes, because that's actually a point right there at -2, -1. So I'm going to include that. Do I want to include 5? No, because that's just a hole in the graph there. That's not actually a point. So that means that we are going to include the -2 but not include the 5. So our domain is going to look like this. The range is going to be how far up does the graph go, how far down does the graph go. Are there any y values that are missing? Well, in this case, our range is going to be the set of all y values. Our y values go from here, a depth of -1, all the way up to the highest it gets is a height of 4 here, right? So in this case, our range is going to be from -1 to 4. Do we want to include those values? Sure, we actually do reach a depth of -1, all right? And so I'm going to include that, and we actually do get all the way up to a height of 4, so we're going to include that. So this would be our range for this particular graph. Okay, so you are familiar, I think, with the vertical line test. The vertical line test goes like this. A set of points in a coordinate plane is the graph of y as a function of x if and only if no vertical line intersects the graph at more than one point. So, for example, if we have, let's do a few different graphs here. Let's say we have a graph that looks something like this. Then anytime I draw a vertical line, it's going through at most one point, no matter where I put that vertical line, one point. But if I have another sketch, let's say I have a sketch that looks like this, looks like a parabola shape opening to the right. Now if I try my vertical line test, now you see it's going through more than one point, right? So that means that this particular graph here is not a function. Okay, so let's talk about what the zero of a function is. And you can look at page 55 for more examples of the vertical line test at work. So a zero of a function, if a graph has an x-intercept, a comma 0, then a is a zero of the function. All right, so the zeros of a function f of x are the x values for which f of x is equal to 0. So if we want to take a look at this example, if we're asked to find the zeros of the function, that means we want to know when is this function equal to 0. So in order to find this, we can just, that's not what I wanted to happen. That's not what I wanted to happen. That's what I wanted to happen. All right, so if we want to find the zeros of the function, we're going to set our function equal to 0. So I get 0 equals square root of 5 minus x, and I need to solve for x. I'd probably square both sides to get rid of the square root. And so 0 squared is 0. Square rooting and squaring are canceling each other out. So I get 0 equals 5 minus x. I'm going to subtract 5 from both sides. So I get negative 5 equals negative x. And I'm going to divide both sides by negative 1. So I get x equals 5. So that would be the 0 of the function. And let's take a look at this graph, and we'll confirm that. Because we're looking at the graph of square root of 5 minus x. Square root of 5 minus x. And we can see the 0 of the function is right there at 5. That's where our graph touches the x-axis. Okay, so now we have these really rather wordy definitions of increasing, decreasing, and constant. So a function f is increasing on an interval if for any x1 and x2 in the interval, x1 less than x2 implies that f of x1 is less than f of x2. So if we can get a little visual of what's going on here, if we have some kind of function graphed like this, and let's say here's an x1 here, and let's say here's x2 here. If we choose any x value in that interval, if x1 is less than x2, and it is, then f of x1 is less than f of x2. Where's f of x1? Well, here's the point, x1, comma, f of x1. And here's the point, x2, comma, f of x2. So I can see that x1 is less than x2, and I can see that f of x1, which would be this depth here, and f of x2 would be this height here, is less. So that implies that this interval between x1 and x2 is an increasing interval. Likewise, we can have a function f is decreasing on an interval if for any x1 and x2 in the interval, x1 less than x2 implies that f of x1 is greater than f of x2. Or we can talk about a function being constant. A function is constant on an interval if for any x1 and x2 in that interval, f of x1 is equal to f of x2. So let's take a look at this example. This is the same graph that we were looking at earlier. So on what intervals is the function increasing? On what intervals is the function decreasing? On what intervals is it constant? So in this case, it looks to me like the function is increasing from this point here all the way up to this point. It's increasing. But how do we express that? Well, we only want to list the x values for which we're increasing. So it looks like we're increasing as x goes from -2 to 1. So I'll write interval from -2 to 1. All right, and then it looks like it's increasing again from this little point here up to this point. So I would say maybe union with 4 to 5, not including the 5. All right, that's the two intervals on which the function is increasing. Well, where is it decreasing? Let's get rid of this. That was increasing. So it looks like it's decreasing here on the interval from here to here. It's decreasing. Right? It was increasing here, increasing here. So in this interval that's decreasing, from what x value to what x value are we decreasing? Well, we're decreasing from 1 to 4. So our interval for which we're decreasing, remember we're always going to express that in terms of what x values would be from 1 to 4. All right, is it ever constant? No, it's not. But if we had a graph that looked something like this, then we could say, oh, it's increasing from this x value to this x value. It's constant from this x value to this x value, and then it's decreasing from this x value to this x value. All right, that brings up relative minimum and relative maximum. Together we would call those the relative extrema of a function. A function value, f of a, is called a relative minimum of f if there exists an interval, x1 to x2, that contains a such that x1 is less than x and x is less than x2, implies that f of a is less than or equal to f of x. Note, that means that f of a is the lowest y coordinate in some interval. And this is just another example of very wordy, very technical definition of a relative minimum, but it's something that's so easy to see if you look at a graph. So let's say we have some function here, and the function, let's say, looks like this. If this is our function, then we can see, let me move this over a little bit, that we can see that this point right here is the highest point in some, in some interval. Like we pick some interval, this point right here is the highest point. So this point would be a relative maximum. Why do we call it a relative maximum? Well, because it's highest point in relation to any points in a little interval around it, but it's certainly not the absolute maximum, because remember, this function just keeps going and going and going, right? So it's certainly not the highest point of our function. Okay, what about a relative minimum on this graph? Well, I think here we see that this point is the lowest point in some, in some interval that we would look at. So we would call this point right here the relative minimum. It's not the absolute minimum because this function is going lower than that, right? It keeps going, keeps going down, down, down here, right? All right, but we do have a relative maximum and a relative minimum on that graph. Okay, so I'm going to skip over this wordy definition of the relative maximum. All right, so let's take a look at using the TI Inspire to graph the function f of x equaling negative 2x cubed plus 3x minus 1. So, and we're going to look at that and we're going to try and find the zeros and the relative extrema. So if I pull up my graph and I want negative 2x cubed plus 3x plus 1, I'm adding a graphs page here. I want negative 2x raised to the third. Right click to get out of that. And then what was the rest of it? It was plus 3x minus 1. Plus 3x, no, x minus 1. Okay, so there's my graph. Okay. And I can see already that I have a relative minimum here. And I have a relative maximum here, so I need to find those ordered pairs. And I also can see that I have 3 zeros because my graph is crossing through my x-axis in 3 different places. So let's talk about how to find these on your calculator. So if we want to find the relative minimum first, that's this point right here that I'm trying to point to, there it is. If I want to find that relative minimum, I'm going to go Menu, Analyze Graph, Minimum. And look, it's asking, hey, where do you want your lower bound to be? So we just need to slide our little pointer to the left of that minimum and click. Now it's saying, oh, where's your upper bound? Well, I have to go to the right of that minimum. Do you see that grayed out area? That's the search zone. That's where you're telling the calculator to look. So if I click here, it's telling me this ordered pair corresponds to that minimum point. So really the relative minimum, you could list negative 0.707 comma negative 2.41. All right, if I want to find this relative maximum, which I'm pointing to right here, I'm going to go Menu, Analyze Graph, Maximum. Again, it's asking for a lower bound, so you got to give the calculator some clue as to where you're looking. I got to go to the left of that maximum and click. Now it's asking for the upper bound. It's giving me that grayed out search zone, and I click again, and it's showing me this ordered pair 0.707 comma 0.414 approximately is the relative maximum. And now if I want to find these zeros, and I'm pointing to a 0 right here, and there's one over here, and there's one over here. If I want to find those zeros, I'm going to go Menu, Analyze Graph, 0, And now I got a bunch to find, so I want to be specific and say if I want to try and find this one right here, I got to get to the left of that one, click, get to the right of that one, click, and it's found it, and it is approximately negative 1.37, comma 0. So negative 1.37 would be a 0 of the function. All right, or at least it's an estimate for it. And if I want to find this one right here, I would do again, menu, analyze graph, 0. I got to get to the left of that 0, to the right of that 0, and there it is. It's 0.366. I got one more to find. That's, I'm trying to point to it, but it's this one. It's kind of like I'm grabbing it right there. So I want to go menu, analyze graph, 0, and I'm going to get to the left of that 0 and to the right of that 0, and it looks like that one is at exactly 1, comma 0. All right, so that's how you use your calculator to find the zeros and the relative extrema. Okay, so let's talk about average rate of change. Let's see, the average rate of change. Actually, I think I'm going to stop this video at this point.